Alright, so I cleaned this all up and I put some tape over the holes, the access holes. That's the screw that I put back. This is supposed to be like this, just to keep that insulation on there. And then I had that was one of the access holes right there. And that's all. Just kind of buttoned up this closet. So I'm still running the AC. I got to go outside. And then after everything is done, I'll come back here and pull that test strip out, so test amps. Alright, first thing I want to do is I want to figure out what the delta T is here. So the air on this comes in the bottom and out the top. So I'll get the airflow coming in from the bottom. .94 degrees coming in from the bottom. So now we're going to write that down on the sheet. So this is an air temperature on the condenser in, right there, 94. Now I want to get the condenser out. See the coil? I have a lot of different points that I could get the temperature from. I want to try to get it from the center, so I'm going to go right there. There's your number, 114.3. Okay, so now we want that delta T. Which is 7 minus 8. 7 is 114.3 minus 8, 94. That's 20.3 degrees Fahrenheit. That is a 20-degree split across this 40-year-old coil. That's a very good number. There's truly no reason to even put refrigeration gauges on here. The system is running fine. But since we're right here, let's go ahead and put the gauges on. Alright, so there's my bucket with my gauges, my HVAC bucket with gauges. And I got to pull this panel door off and figure out how to get gauges on here. So let's get right to it. Schematic on the back. That's just the panel door. I've been in here before and I had to do a schematic by hand, so I just had it laminated so I could stick it in there. There's your gauges. The smaller one, that's going to be the high side. The larger in diameter one's going to be the low side. Got caps on it. Let's see what we got here. I haven't used these gauges in a long time. They still have a little bit of pressure in here. It should be R22. Make sure all my valves are closed. pull off the caps. It's been so long, I've never actually put gauges on this unit, 9 years ago. So I'm just going to double wrench this just to make sure I don't break something. Boy, that cap is tight. There it goes. I do not see a Schrader valve insert, so it won't depress the Schrader valve. Okay, now that I'm at the service valve, this service valve should be back seated 100%. I want to go cracked off the back, so I have to go to tighten it in order to get this port activated. So, alright, so this is the right size. I want to make sure that I got my wrench going the correct way. I should be able to turn this way, and this gauge needle should pop up. There it is. I got it. 65 psi. I'll show you a close-up on this in a second. Let's go ahead and check the high side. The last service tech really tightened these up. Alright, let's go on this one now. There it is. Okay, let's show you those gauges. Then we'll start filling out our check sheet. Alright, there's your gauges. Your low side is at 65. Your high side is at 285. So let's write that down. 65 and 285. Alright, so now we're dealing with refrigerant temperatures and pressures. We are at the condenser. The condenser after the compressor, that's going to be your high side pressure. It tells you right here. High side pressure and the corresponding temperature. We said it was 285, right? Now the low side pressure is 65. So the low side pressure is right here, and that one there is going to be 65. To get these corresponding temperatures, we need to look at the gauge, and it tells you right on the gauge. Alright, so on the low side, you'll see that it's about 66, right? Then you want to look at the green scale for R22 on the inside, and you want to get that corresponding saturation temperature. That number is 38. So we want to write down 38 under saturation temperature. That is over here, corresponding temperature, 38, like that. We want to do the same thing for the high side. So, the high side is saying about 290 or 287. 287. What's that saturation? That is 38 128. So let's write down 128 right here. Now, let's see what other information we can get here. We would like to know what the actual low temperature is. Now ideally you want to get that right after the evaporator, but we're going to get it right down here somewhere. So we got to figure out where we're going to get it. So I'm looking at this pipe right here. That's perfect. I'm going to get it right there because that's uninsulated and it's just perfect. I have a special tool to get that. That's this right here. So we want to put that on there and get that ready and get that into my meter. Okay, so I'm using my field piece. I got that thermocouple for pipes plugged in. It's plugged into the type K connector right there, you can see. And I got it set to temperature 400 degrees. And the temperature that it's just giving me right now is 42.4. That number is the actual low, 42.4. So that number is going to go right there. That's going to be number 3. In order to get the superheat temperature, you're going to take 3 and you're going to subtract the saturation temperature, number 4. So it's 42.4 minus 38. 42.4 minus 38 is 4.4. So the actual superheat here is 4.4. That number's real low. And I think we have a fixed metering device and you're supposed to use superheat for the rating. Now, it'd be nice to know what the compressor amps are. I'm going to have to pull off that door in order to try to get compressor amps. Let me try to do that. This is what it looks like inside that panel. You can see a capacitor right there, contactor right there, and looks like a relay right there. There's another capacitor right there. Well, we can check that stuff out later. Right now, it turns out that I can get the amps without pulling the door off right here. So I was able to grab a leg right, that yellow leg right there, and then I put my meter on hold. And it turns out that the compressor amps is running 8.27. We're going to put that down right here under compressor amps, 8.27. Now if I have a data nameplate, I can get the rated amps. There's the rated nameplate right there. They installed it on the back side, so I'm going to have to use my cell phone, take a picture, see if I can get the rated amps. Alright, I took a picture of that data plate right there with my cell phone, but the numbers are so, you can't read it, so I cannot tell what the rated supply fan amps are. I put my pipe temperature clamp on the liquid line going into the house, which would be the condenser outlet temperature, and there's the number right there. About 103.5. When I did it, it was 101. Now I want to also get the temperature of the refrigerant leaving the compressor to see how hot that is. So that's going to be this line right here. Get on that. And that will tell me how hot this is. That's jumping up, which it should, because because that's a really hot temperature. Another thing I'm going to do is physically put my hand on the top of the compressor, and this compressor is slightly sweating, which is good, meaning that this compressor is running cold, not too hot, which is good. I don't want this motor to overheat, because there's a motor inside there of this hermetically sealed compressor. So right now I just want to get this temperature here, figure out what that is. Call it 165, 166. So that's going to be 166. So that's going to go right here. Should not exceed 225, otherwise you're getting too hot and you're burning out your oil. But we're fine. Okay. Let's go ahead and figure out the subcooling, just in case this was a TXV. We're going to take the corresponding temperature here, and we're going to subtract it by the condenser outlet temperature there. So it's 128 minus 101 is 27. So that number right here is 27 for the subcooling temperature. Now this unit is so old I don't even have a chart to tell me what the subcooling should be on this unit anyways. And this one here I don't think is a TXV. This is the one that's really more important. Okay, so judging by all this information that I have here, and going by the superheat method, because I think we have a fixed metering device of 4.4. Now I don't have the manufacturer's spec of what that should be, but if I just use a rule of thumb that the superheat level should be between 8 and 13 degrees, that number is low. So it tells you if the superheat level is low, there is too much charge, and if it is too high, there is not enough refrigerant. So if anything, this unit is slightly overcharged, and that is why that superheat level is giving me that low level number right there. So if anything, we're towards a little bit overcharged, but in this case, it's not really harming anything. It's been running this way for years, so I am going to button this puppy back up and call it a day. Now, let's go ahead and get the manifold gauges. We've got to remove our hoses off of these lines. First thing that we want to do is we want to close the highest pressure. So the liquid line is going to be the highest pressure in the system. We're going to backseat that valve 100% all the way and get that 100% closed. Okay, this is the liquid line service valve. I want to backseat that 100%. So I want to get my service wrench on there. And I want to go back, so it's going backwards, or left, or counterclockwise. Get that nice and tight. I don't want to leak here now that I'm closed. So I'd like to do a little leak check on it with my Blink Blue, see if there's any leak. We're looking good. We're not leaking at that joint right there. I go ahead and put the cap back on. I want to get this pressure out of the high side, push it back into the low side. We're going to open up the high side and the low side until my gauges equalize. Right there, they've equalized. Now I'm going to go ahead and shut the low side, shut the high side. Now I'm going to take the low side service and backseat that 100%. Now that that's closed, I'm going to take my big blue and look for any leaks. That looks pretty good, no leaks. Go ahead and put my cap back on. I'm going to go ahead and go to the thermostat and shut this off. I don't need it anymore. Okay, I shut the unit off so I could talk and I wouldn't have to talk over the compressor. Now that I've got my gauges kind of in a position where I can pull that off and not have to, I don't need the compressor anymore. So since I don't need electricity, I don't need the unit, I'm going to pull this disconnect off because I wanted to check those capacitors out while I'm here, and I got that off. So I'm going to pull this out and I'm going to put it on top so I don't have to worry about electricity and getting zapped. And now we'll go back to this section over here and show you what I'm doing. I don't need this. Pull that off. Okay, this cap is on, it's on tight, it's fully back seated. I'm putting this cap on right here. I don't think I tightened it up yet. So just to double wrench that to make sure it's not going to cause me any issues. Just to give it a little extra support. Okay. Now we're going to go ahead and pull off our hoses off of the system. Now let's see if these are tight. Got my big blue. Actually, these service valves look good. I don't see a leak, which is amazing. It's a 40-year-old system. I'm going to put my caps on. The system is slightly overcharged and there is no leaks on the system. It's just been an amazing system for the age. Absolutely amazing that I'm getting this life expectancy out of this unit. And I'm just going to milk this puppy out till it don't give milk anymore. I'm not going to go and buy a brand new unit till this thing is toast. I mean toast, toast, triple toast. Okay, so let's get these caps on tight. Okay, it's good. Now, I would like to check out these capacitors. Capacitors in order to do a check on those for the microfarads. Alright, let's see if we can start with this one here. Let me try loosening that, pulling this forward. Okay, wow, that's a 124 to 156 microfarad. Wow. Alright, let me discharge this capacitor. Then I'm going to pull one of the leads off. Then I'm going to go ahead and take my meter and we're going to go ahead and check it and see what we get. Okay, we're on microfarads. Let's get on here. $138, and it's rated for 124 to 156. That one's good. Put this back together. Make sure I've got the spade in correctly. And this time when I put it in, I'll leave it so I can kind of leave. I don't have to do that again. So I can read it right here. As long as it's tight, and it is tight. Now, for the other two, first let me go ahead and discharge by shorting out the two leads. Okay, that's good. I'm good on both counts. Now, let's see here. I'm going to have to loosen the strap to lift these up so I can see. Okay, I'm loosening the strap. I'm going to have to get a better nut driver here. I have an extra one in here. Hold on a second. What size is that? Oh no, I need a 1/4 inch. Oh wait, do I have a 1/4 inch here? Actually, I got one. Okay. Okay, we're loose. Good. Okay, 7.5 microfarads on the one in front. So let me pull off one of the leads, do the same process I just did with that other capacitor. Come on. That's almost there. Okay, one of the leads is pulled. Got it on microfarads. Let's go ahead and check. .28. It's rated at 7.5. That's perfectly fine. That capacitor is good. Let's move on to the one in back. Oops. Okay. Now the one in back, I can't read. There it is. 45 microfarads. So I'll pull off one of the leads and do the exact same thing. .46 microfarads. It's perfect. All capacitors are checking out 100%. So let me put this back in. So what I'm going to do now, because this is the door that goes on right there, I'm just going to do a little drawing here. Write down capacitor, and that one there is 124 to 156. 124 to 156 UF, which stands for microfarads. Now there's two capacitors here, like that. This one here in the back is 45 microfarads. And this one here is 7.5. The 7.5 one must be for the supply fan. The 45 is for the compressor. The one in the back is maybe a hard start kit for the compressor. Okay. we're good. Let's get this all back together. Make sure my strap is tight. Hold on a second. Actually, I can leave that just... I wonder if I can do this so you can see it. Let me see if I can spin this around. Alright, so on the plate, what I did was 3 capacitors. This capacitor is 124 to 156. And then if you look at that rating, the video camera seems to be losing focus when I go in too tight. Alright, then there's 2 capacitors right there. This one here, I just wrote it down right there, 7.5 microfarad, because this plate here blocks it. There's nothing I could do about that. The one in back, oh come on, the one in back, you can kind of see right there that it's 45 microfarads. So I just tried to get it as visible as possible. All of this is good. I am ready to button everything up here. Might as well take my big blue that I've got here and just verify that we're good here, good here. Put the caps on. Want to try to see if there's any leaks at all. My battery died on the camcorder, so I checked it while the battery was dead, but just to go over it one more time with you YouTubers, I went over this real good, looking for any possible leaks on the system at all that I touched. I touched, for the refrigerant, I touched these points right here. So I want to see if I am going to produce any bubbles here telling me that I got a leak. You know, this stuff here, brush on blue, well worth the $5 or whatever it is for the bottle, so tell you exactly what's going on with your system. Alright, so I don't see any leaks. We look good. I got to put this panel door here back on. I've got to clean up everything, so give me a few minutes and we'll wrap. Okay, so I've got the panel door here. I was getting ready to put it on, and then I noticed on the back that it had a schematic, and I just wanted to show that YouTube land. So I changed out this condenser fan motor in the past. When I did so, the fan must have been a 2-speed motor, and I just took amp draw readings on the motor, so I got the high amps and the low amps. I can't even remember what speed I ended up setting it to. I just don't remember. Anyways, here's the schematic that is on the back of this plate. But I also had gone through a couple years after I moved in, these internals, they burnt up on me. I had to replace some components. It looks like I replaced that contactor, that capacitor right there looks new. That contactor I'm sure I replaced. I can't remember if I did this component right here. I think I did do that one there. And definitely I put in that 7.5 microfarad, because I wouldn't do a condenser fan motor without a new capacitor. If you do a condenser fan motor or any fan motor that has a cap, change the cap when you change out the motor. That's standard operating procedure. Now, it looks like I also kind of drew out my own schematic here. I don't know. So anyways, I just thought I'd show you this schematic while I was right here and was fooling around with this. Looks like I wrote down here that there's the start cap. 135 to 155 is that microfarad. So that capacitor there is not it must be the start capacitor, obviously. That's it. So let me go ahead and put this back together. Okay, that concludes the video. So you saw the checklists. I had 2 checklists. This one here was pretty much for the AC, and the other checklist, which is this one here, is pretty much for the furnace. You saw me fill out both of them in great detail. If you want these checklists, so you can request them on my website. There's a link down at the bottom for you to do so. I hope that this video was informative. It was not necessary for me to put gauges on this unit, judging by the temperatures alone. I only put the gauges on the system because I just wanted to go through and fill out the checklist 100%, create a baseline. I've been living here for almost 10 years. I never even put gauges on this system. Why? Because it wasn't broken. I just felt like it was, if it ain't broke, don't fix it. And for the cooling, the refrigeration cycle was working fine. Of course, I've been washing my filter every so often. In my case, we run the thing so little, I only need to wash the air filter twice a year. Once for the heating system and heating season, and once for the cooling season. That's it. But anyways, you saw my delta T's. I've got greater than 20-degree splits across the evap and the condenser coil air temperatures. If you're seeing things like that and your air filter is clean and you're getting good airflow and you're not restricted, your system's probably just fine. You don't need to do anything to it. But anyways, I just wanted to go through all the different steps that you can check. As a DIYer, I can check my capacitors, I can do stuff like this and just see how everything is operating. I hope you found this video informative. Please click on like, give me an extra like, subscribe to my channel, Ken Training. Check out my other videos, I've got plenty of them. I will see you later.